Today, we want to take a look at graphing inequalities, but before we can do that, we need a refresher on how we graph things. So let's say we want to graph y equals 4x minus 1. Remember, when it's in this form, it's called slope-intercept form, and the number right here is the slope, which simply describes the steepness of something. It's like a wheelchair ramp. How steep is it? Or a hill. If I got to climb up something, would you rather climb up that or something like that? I'm lazy. I want this guy. Okay, I want something that's not quite as steep, a lower slope. So this guy has a slope of 4, meaning it rises 4, runs 1. This is your y-intercept. It always tells you where it crosses the y-axis. So in this case, I know it crosses at -1. And now that I have a point, I can get another point because I know what the slope is. The slope, it rises 4, runs 1. So I go up 1, 2, 3, 4. I go to the right one. If it's positive slope, I always want to aim up to the right. If it's a negative slope, you'll aim up to the left corner. Okay? Take a look at another. So I know it's crossing the y-intercept at -3, so I'm going to plot -3. Has a slope of -2. Negative simply means it's going to aim and hit up that corner. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And then there's my line. And there's my graph. Is that simple? Hopefully this is refreshing your memory. Y-intercept -1. So this guy's crossing right at -1. Has a slope of 2/3. Now I don't want to try and go up 2/3 over 1. We just go up 2, 1, 2, and now it's positive. So I'll go 1, 2, 3 over this way. 1, 2, 1, 2, 3. Now I could drop 2, and I know to go this way because I know I need it to aim up towards that corner since it's a positive slope. And there's my line. So now what's different here with graphing this? Well, it's an inequality. Okay. That means one of the sides is going to get shaded because there's an infinite number of points here that are solutions. I mean, if I pick x to be 1, I know 2/3 times 1 minus 1. I know 8 will be bigger than that. So I know 1/8 would be a solution up here. I know 1/7 probably is a solution. I bet you 1/6 is a solution. Probably 1/5 is a solution because 2/3 times 1 is 2/3 minus 1 is negative. So yeah, all these are going to be solutions. You have solutions all over the place. So what we need to do is decide where's that boundary line? Where is that line? And that's what we're looking for. And it's simply the line y equals 2/3 x minus 1. So we just simply erase that. I'm going to go ahead and plot -1. I'm going to say, hey, 2/3 up 1, 2 over 3, just like the last problem. Now notice it says or equal to. That means the line itself is included. So we are going to make it a solid line to include the line to say, hey, these points on here are perfect. They work. They make it true. They actually make it equal. So now notice you got one of two things. Either you're on this side or you're on that side. Okay, everything's on one side or the other. We already said, hey, you already told me it was over here because you showed me points that worked. Well, yeah, correct. And the easy way to know is if it's written, it needs to be written in this form, which we will be writing them. It's written in that form of slope-intercept. If it is greater than is sort of like up high. That means you're going to be on the upper side of that line. So I know all these points, I shade that upper side. If it had been a less than, that means it would have been underneath that line. So I would have been shading down here. So again, greater than, you'll shade above the line. Less than, you'll shade below the line. All right, so let's graph y is less than -3/2 x minus 1. So I plot -1, my y-intercept. I go up 3, 1, 2, 3 over 2. But since it's a negative slope, I go over to the left. 1, 2, 3 over 2. Now, notice it doesn't say or equal to. It doesn't have that or equal to on there. That means the line itself is not a solution. The points will get right up to the line but won't touch it. So how do we indicate to people, hey, the line's not a part of the solution? We make a dashed line. A little crooked. Now I got to decide, are my points over here or over on this side of the line? Well, since it's a less than, that means it's going to be under the line. So if you imagine this line's a mountain and you're walking, you'd be walking up this side. That's the upper, and the sky's up here and everything. So this is the underside. So this is the part you want to shade underneath the line. So when equations are in slope-intercept type form, greater than will shade above the line and less than will shade below the line. All right? So what inequality, we're changing up things here a little bit. What inequality is graphed here? We got to figure it out. Well, not very difficult. I got to figure out the equation. I notice it's shaded, if this is my line, it's shaded what? Above. Notice that arrow is pointing up. So it's great. So I know this is y is greater than. Now, let's figure out the equation. Well, I see that I see that right there is the y-intercept at -3. So I need my slope and then my y-intercept. And in this case, the y-intercept is -3. So it's going to be -3. We know its y is greater than or equal to because it's a solid line. I don't know how I messed that up. And now the slope, it seems to go up 2 over 1, up 2 over 1, up 2 over 1. So there's what I have graphed. Y is greater than or equal to 2x minus 3. The next one, we shaded below. So it's y is less than or equal to, because it is a solid line. Well, all I need, I see the y-intercept is -3, so it's going to be -3 here. The point, I can't, yep, it looks like you go up 1 over 2, up 1 over 2. So it's 1/2 x, and it is a positive slope, so I don't need to put a negative there. So that's what we have graphed there. And back here, again, it was also a positive slope. Y is greater than. So greater than because it was shaded above. And then here, since it was underneath, we use a less than. Solid line, put the or equal. There we have graphing inequalities.